In this video, you're going to be learning the difference between intra and intermolecular forces. As you're watching this video, you should be taking notes on page 1 of your packet of fun. If we take a look at the first page on your packet of fun, you're going to see this picture. And you notice in this picture, there's a dotted line between two HCl molecules, and there's also a single line representing a chemical bond between atoms within an HCl molecule. Each of these forces of attraction are called forces of some type. One of them is an intramolecular force, the other one is an intermolecular force. Intramolecular forces are basically any chemical bond that we've learned about in the past, whether it's covalent or ionic. Whenever you have a sharing or a transfer of electrons, we call that an intramolecular force. An intermolecular force is the force of attraction between the molecules themselves. So you don't ever just see a single HCl molecule, you always see a bunch of HCl together. What that means, since they're all stuck together, there's forces of attraction between those molecules that make them stick together, or instead of saying stick together, they're just feeling an attraction toward one another. Intramolecular forces, so any ionic or covalent bond, is a force of attraction within a compound. It is much stronger attraction because there's an actual transfer or sharing of electrons that are happening. So if we take a look, here's a little recap on ionic and covalent. Ionic, you have that transfer of an electron, and covalent, you have sharing. These are two chemical bonds, and these are considered intramolecular forces. So the force of attraction between atoms in a compound or molecule. An intermolecular force is the force of attraction between the molecules themselves. So if we take a look at these two water molecules I have here, an intramolecular force is the actual covalent bond in between atoms of a water molecule. But we don't ever see just a single water molecule in nature. We always see water sticking together. So there must be an attractive force between water molecules. We call the attractive force that comes between the water molecules an intermolecular force. One more thing I want to point out is at the bottom of the first slide on intermolecular forces. Dependent on how strong or weak your intermolecular forces are, it will let us know what state of matter they exist in nature. So does something naturally exist as a solid? Well, then they probably have a very strong intermolecular force where they stay very stuck together. Versus something that maybe exists as a gas in nature, so they don't really have many attractive forces between them, and so they don't stick together as much. Or maybe there's some in-betweeners where they kind of stick together but not close enough to be solids but close enough to move past each other, and then we get something that naturally exists as a liquid. So if you take a look at these bullet points here, it says that intermolecular forces affect which state of matter a compound will be, and it also impacts physical properties such as melting point or boiling points of compounds. So if something has a very strong intermolecular force, then the melting point is going to be a lot higher than something with a weak intermolecular force or something that's held loosely together. It'll be easier to separate those things in those physical changes, and we'll get to that later on in the unit. So again, just as a recap, intramolecular forces are the actual chemical bonds within a molecule. Intermolecular forces are weaker forces of attraction, but they do still exist, and they're the forces of attraction between the molecules themselves.